Welcome back, ninth grade. I hope you had a wonderful Easter and are willing to work hard for 28 more days until the end of school. Hopefully we'll be able to see each other before that, and we'll have mouse traps. I think that would be fun. Okay, after everybody is so crazy. Maybe it will not happen. If it doesn't happen, God bless you all. Just to stay safe and don't drive your moms crazy. Okay, so let's look at calculations using molar mass. If you remember, the mass of an element on the periodic table was essentially we're using the atomic mass units from the periodic table and weighing them in grams, right? So if you say hydrogen, and hydrogen has an atomic mass of 1, okay, that's here, which means it doesn't have any neutrons, it's just protons, so it has an atomic mass of 1, and I want to know how much that hydrogen gas would weigh. Well, there's 2 hydrogens, they each weigh 1. That means that there are 2 grams in every mole of hydrogen. Okay, 2 grams of H2 in 1 mole of H2, right? If we were to take oxygen, okay, oxygen has atomic number of 8 and a mass number of 16. If it has a mass number of 16, that means it weighs 16 grams for every mole. Okay, so 16 grams of O in every mole of O. Well, what about O2? Well, each oxygen is 16, and there's 2 oxygens in O2. Okay, so that means it's 32 grams of O2 in 1 mole of O2. All right. What about a compound a little bigger? What if you were to have water? Okay, so we have H2O. We see that H in the periodic table is 1, and there's 2 of those, so I need to think of 2. And then oxygen is 16, so 16 plus 2 is 18. That means there's 18 grams of water in 1 mole of water. Now that's really useful because I can take glass and put it on my scale and measure 18 grams of water very easily. Okay, so if I knew that I had 18 grams of water, I also know that I have 1 mole of water. And 1 mole is not a weight. 1 mole is an amount. It's an amount of molecules, or an amount of atoms if you're doing atoms. Okay, and we know that in 1 mole, you're going to have 6.022 times 10 to the 23rd somethings, okay? In the case of water, you would have 6.022 times 10 to the 23rd molecules of water. In the case of hydrogen, you'd have 6.022 times 10 to the 23rd atoms of hydrogen, right? So you can, just by knowing the conversion factor, or knowing the molar mass, I can convert between grams to moles and then moles to atoms or molecules. Extremely useful. So for instance, I can take something on my lab table and measure it out and know, based upon its mass, exactly how many molecules I've got. That's ridiculous. That's awesome. And then I would know how many of those are going to react with how many of the other ones. So chemistry uses numbers, not just to make your life hurt, but it uses numbers so that we can compare things that we know, and then find out things that we're looking for. So here is the idea of a conversion factor. If you have an equality, you can have a conversion factor. So if I know that, for instance, there are 18 grams of water in 1 mole of water, then I can, that's an equality, I can set it up as a conversion factor. Now, what you're doing with a conversion factor is multiplying by the number 1. Okay, let me give you some examples. If I have 2 and I divide it by 2, 2 goes into 2 one time. Okay, 3 goes into 3 one time. 10 goes into 10 one time. Fred goes into Fred one time. Okay, Fred doesn't go into Fred times. Fred goes into Fred one time. Okay, so anything divided by itself is 1. So what if you have different units? What if you had 7 days in 1 week? Well, 7 days is equal to a week. Those are an equality. So if you put something to where that they've got different units top and bottom, and I have something like weeks. Here's an example. I have 3 weeks. If I multiply by the number 1, I haven't changed its value. Anything times 1 is still 1, or anything times 1 is itself, I'm sorry. So if I confuse this one and make the top and the bottom different, then what will happen is that weeks on the top will cancel with weeks on the bottom. And you've changed the units now from weeks into days. Now, so you'll take any of the numbers top and multiply, and then divide by any of the numbers on the bottom. You don't really need to since this is a 1, but 3 times 7 is 21, divided by 1 is 21, and so now I'm in days. So you went from 3 weeks to 21 days. Now some of you can do this in your head, but you wouldn't be able to do on paper. But what you're looking for is you're looking for a number 1 where the top and the bottom are equal to each other but expressed in different units. So if I have 1 mole of methane gas is 16.4, now how did I get that? I went to the periodic table, I found that carbon was 12 grams per mole, and that hydrogen is 1 gram per mole, and took 4 hydrogen, so I took 4 ones and added it with the 12, and ended up with 16.04. And if you take the numbers that are on the periodic table, you're more specific. I just did it kind of roughly. So 16.04 in this case. Well, if those two are equal to each other, I'm going to set up 2 possible conversion factors. Okay, 1, and then the flip of that 1. So 16.04 grams of methane to 1 mole of methane, or flip it upside down, 1 mole of methane to 16.4 grams of methane. And which one do you use? You use the one you're trying to get rid of. Remember here with the 3 weeks and 7 days to a week? If I had weeks, I want to put weeks on the bottom so that they cancel each other. Okay? So if I have, for instance, 2 moles of methane, I would use this one because moles of methane is top, moles of methane is bottom. Now they cancel. My answer now is in grams of methane, and I do it 2 times 16.04 divided by 1. Okay? If I had something else, in fact, if I had 3 grams of methane, then I would choose this one on the right, because 3 grams of methane, I've got grams on the top and I've got grams on the bottom. They cancel. When they cancel, the only thing that's left is moles of methane, and that's where I'm trying to go. So I would take 3 divided by 16.04, and that would tell you how many moles that I have. Here's an example. Acetic acid gives a sour taste to vinegar. Write an equality and 2 molar mass conversions. All right, got my calculator. I look here and I see 4 H's. An H plus 3 more. H is 1 on the periodic table, so I'm going to put a 4 in my calculator. Carbon, I'm going to look on the periodic table and see that carbon weighs 12 grams per mole. There's 2 of them, so I'm going to add 24 to my number. Okay, so far. Then I look over and I've got 2 oxygens. Oxygen on the periodic table is 16. I've got 2 of them, so 2 times 16 is 32. So I'm going to add 32 to it, and I'm going to see that there are 60 grams of acetic acid. I'll just put acetic acid in 1 mole of acetic acid. Okay, so it doesn't matter which way I put it. I can put 60 grams to the mole, or I can put 1 mole to 60 grams. I use that conversion factor depending upon what I've got. If I've got moles, I want to put moles on the bottom. If I've got grams, I want to put grams on the bottom so that I can cancel and get the other side. Okay, so they're asking for an equality. Well, the equality is that 60 grams of acetic acid equals 1 mole of acetic acid. That's your equality. and 60 grams of acetic acid over a mole is 1. Your other possibility is 1 mole of acetic acid over 60 grams of acetic acid. Make sense? Hope so. Aluminum is used to build lightweight bicycle frames. How many grams of aluminum are in 3 moles of aluminum? All right. First of all, I go to the periodic table. I look for the weight of aluminum, and I see that aluminum is almost 27. So let's use 27. I'm given moles. Let's write that down. 3 moles of aluminum. So what do I put on the bottom if I've got moles of aluminum up at the top? I want moles of aluminum on the bottom and the grams of aluminum on top. So I go to the periodic table. How many grams are in 1 mole? In 1 mole, there are 27 grams. So that means moles of aluminum cancel. My answer will be in grams of aluminum. And how do I do the math? Top times top divided by bottoms. Okay, so I have 3 times 27 divided by 1. Now, usually if 1 is going to be the same number, I just ignore it, but it does not matter. You'll get the same thing. So 3 times 27 gives me 81, and I'll end up with 81 grams of aluminum. So here's another one. Aspartame is C14H18N2O5. Ugh, I hate this. I know that 12 is carbon, so 12 times 14 is 168. So let me just make me a list. Carbon is 168. Hydrogen, I've got 18, but they're only 1 each. Okay, so hydrogen means that's just a total of 18. Nitrogen, when I look on the periodic table, it's 14. So 2 times 14 is 28. And oxygen is 16. And I've got 5 here. Okay, so 5 times 16 is 80. Now we just add this up. 80 plus 28 plus 18 plus 168. And I get a total of 294 grams per mole of aspartame. For 294 grams of aspartame in 1 mole of aspartame. Now your question is 225 grams. Well, what do I put on the bottom? Do I put moles on the bottom or grams on the bottom? Okay, I want to get rid of grams. So I'm going to put 294 grams in 1 mole. Okay, the number you get from the periodic table will always be the grams. So in the case, grams cancel with grams. My answer will be in moles. And my math is take 225 divided by 294. Okay, or if you want to, 225 times 1 divided by 294. And you end up with 0.765 moles of aspartame. Allyl sulfide is a compound that has the odor of garlic. How many moles of allyl sulfide are in 225 grams of it? Okay, well, carbon is 12, and you eventually start learning these. 12, and I want how many of them? 6. Okay, so we've got 72. H is 1 each. I've got 10. That means I've got 10. And sulfur, I need 1, and I'll look at the periodic table, and it's 32. So 72 plus 10 plus 32 gives me 114 grams per mole. Now, they're asking for how many moles are in 225 grams. So now, here's my problem. 225 grams, well, what do I put on the bottom? Do I put moles on the bottom or grams on the bottom? Well, I want to get rid of grams, so I'm going to put the 114 grams on the bottom, 1 mole on top. Grams will cancel. My answer now will be in moles, and my math is 225 times 1 divided by 114, which is 225 divided by 114, 1.97 moles of allyl sulfide. So here is a schematic, kind of a mind map showing you how to go from anywhere to anywhere. So if we know what the grams of an element are, in order to go somewhere else, we need to know how many moles of an element are. We want to know how many molecules I've got. If I know how many molecules that I have, a number, a numeral, then I can go somewhere else. The grams of everything weighs different. If everything has a different weight, knowing something weighs 12 grams doesn't help me. But knowing that I've got 6 dozen eggs tells me something. Okay, I may not know I've got, 14 pounds of eggs. I wouldn't know what that means. I need to put it in a usable form. So moles in chemistry is a usable form. Moles gives me a numeral. It's a number. It's an amount of things that I have. Okay? Even though that it's an enormous amount, it's a huge number, and I've got 6 of those or 10 of those or 50 of those, it's still an amount, then in that amount I can go somewhere else. So if you want to go from grams to moles, you divide by grams. Okay? You get rid of whatever you have. If you have moles and you want to go to atoms, well, in 1 mole, there's 6.02 times 10 to the 23rd particles. That means you divide by moles, multiply by atoms. Okay, so this kind of gives you a mind map of going from anywhere to anywhere. There's nothing I can't ask that you can't do. Here's a last question. How many molecules of water are in 24 grams of water? All right. Well, first of all, I need the molar mass of water. Oxygen is 16, hydrogen is 1, and there's 2. Okay, so that's a total of 18 grams per mole. So let's start with what we're given. We're given 24 grams. So what do I put on the bottom? I don't want grams, I want moles. Go to moles. So I'm going to put grams on the bottom. I've got 18 grams in 1 mole. Okay, because there's 18 grams in a mole, or 1 mole and 18 grams. It doesn't matter which way. Now grams will cancel. My answer is in moles. What is 24 divided by 18? 1.33 moles. Okay, so if I've got 1.33 moles of water, how many molecules of water do I have? Well, I know that in every mole there are 6.02214 times 10 to the 23rd molecules. Okay, moles, I put mole here on the bottom so it would cancel, and then my answer is in molecules. So 1.333333 times 6.022 times 10 to the 23rd gives me 8.029 times 10 to the 23rd. So that must be my answer. I hope that is clear enough for you. You can always go back if there's something confusing. Maybe it would help to retrace your steps just a bit. And I am praying for you. I hope you're doing well.